And so here we have a box contains red and blue marbles. The ratio of red marbles to blue marbles in the box is 8:3. So select each statement that could represent the number of red marbles and blue marbles in the box. And so remember that this ratio is going to be 8/3. If we write that as a fraction. And so let's go and take a look at these statements here. Let's figure out which ones are false and which ones are true. So the first statement here, it says there are exactly 3 red marbles and 8 blue marbles in the box. So the ratio of red, so red is in the numerator and blue is in the denominator. So we can say that that statement's already false because we already know there's only 8 red marbles and 3 blue marbles. And so what we can do for the rest of these is figure out if we have some equivalent fractions here. And so say for instance, if I multiply the top and bottom by the same number, let's multiply top and bottom by 6. I can rewrite the ratio 8/3 as 48/18. So I can say that if I keep the ratio the same and if I add in 8 red marbles and 3 blue marbles, I can double the ratio, I can triple the ratio, I can keep multiplying by a number. And so I can say that there could be 48 red marbles and 18 blue marbles. And so I can circle the last statement in here. I can also go ahead and say, what happens if I multiplied 8/3 by 8? So we can test the 64 red marbles. So I know that 8 times 8 gives me 64. And whatever I do to the bottom, I do to the top. So I have 64 and 24. So that one works. So I have 2 statements here. But to get to 18 and 13, 18 is not a multiple of 8, so I can cross that one out right away. So right here I have 2 statements that work for this problem. So I have here the board contains stars and triangles. The ratio of triangles to stars is 3:1. So for every 3 triangles, I have 1 star. Select each picture that could represent the number of stars and triangles on the board. And so for our first set here, let's count the triangles. 1, 2, 3, 4, 5, 6. I have 6 over 2 stars. If I simplify that simplifies to 3/1. So I can go ahead and circle that one. Let's go ahead and figure out triangles again. I have 2 triangles, and I have 1, 2, 3, 4, 5, 6 stars. That simplifies to 1/3, so that's no good because our fraction needs to, when we simplify, it needs to be 3/1. Let's go ahead and try this third option here. So let's count the triangles. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 triangles over 1, 2, 3 stars. And if I simplify it by dividing the top and bottom by 3, it gives me 3/1 as a ratio. So I can say that this last one works also. So here the model is shaded, represents 1 whole. Thank you for that information. So now write a fraction, decimal, and percent to represent the shaded part of each model. And so what we can do is let's start with the fraction because the fraction will be the easiest to work with. So our fraction for our first one would be 3/5. That's the same if I was going to make this as a fraction over 100. And I multiply the top and bottom by 20, gives us 60/100. So I can say that that percent is going to be 60% or 0.6 as a decimal. So what about the second model here? Let's count all the pieces. 1, 2, 3, 4, 5, 6, 7, 8. I got 9 pieces, and I have 6 that are shaded. So I have 6/9. I can simplify that to 2/3. And I can know something about my thirds. 1/3 is the same as 0.33 with a line over it. So if I have 2 of those, I can multiply that by 2 to get 0.66 with a line over it. So I can say that our decimal is 0.66, and that repeats forever. Or I can write that as 66.6 with a line over it percent. So now we have this question. Jill has 3 full pans of brownies. Each pan was the same size. She gave 3/8 of the original amount of her brownies to her friends. She gave 1/4 of the original amount of brownies to her teacher. Exactly how many pans of brownies does Jill have left over? So we have to figure out 3 different things here. So our first step is, how do we figure out 3/8 of the total? So what we can do is we have the 3 full pans of brownies, and we're going to multiply that by 3/8. So 3 becomes 3 over 1 as an improper fraction, and then we multiply across. And so we can say that she has 9/8 that she's given to her friends. And you know what? For the sake of this problem, let's go ahead and leave it as an improper fraction. Because what we have to, next step is we have to figure out how much she gave to her teacher. So out of those 3 pans of brownies, so I'm just going to automatically write it as 3 over 1. She gave 1/4 away to her teacher. And when we multiply across, she gave away 3/4. We have to figure out how much does Jill have left over. And so what I'm going to do now is I'm going to add 9/8 plus 3/4. So when I go ahead and add these, we have to have common denominators. So the 3 is a 6, the 4 is an 8. So we have 9/8 plus 6/8. So she's given away 15/8 of this 15/8 of the pans of brownies. So what we have to do is we have to subtract it from 3. So we know how much she gave away. We have to figure out how much does our friend Jill have left over. And so what we can do is we can change 3 into an improper fraction. So sorry, I'm going to start right underneath at the bottom of the question. So 3 is an improper fraction, it's 3 over 1. But if I want to subtract this, let's have a denominator as 8. So 1 times 8 gives me 8. And 3 times 8 gives me 24. So if we work with the improper fractions, we won't have to really worry about borrowing from the whole when we go ahead and subtract. So if we have 24/8 minus 15/8, when we go ahead and subtract these, she's left with 9/8 or 1 1/8 pans of brownies. So here you have 3 steps. So take your time with each step. So we know we need to figure out 3/8 of the original amount and 1/4 of the original amount. So we figured out those numbers. And then we have to make sure that we read this final question for step 3. So it's going to take a little bit of time and effort, but I know that when you follow each step and take your time with this, break it down one piece at a time, you'll be successful at this problem. So here Kendra recorded the amount of water she used in 1 week for 4 activities. And so here you have bathing, doing laundry, washing the car, and cooking. So we have 2 questions here. So what's the total amount of water in gallons recorded for these activities? So our very first step for this is let's go ahead and add the mixed numbers that already have common denominators. So I'm going to figure out 3 1/4 and 10 3/4. So they both have a denominator of 4. So when I go and add these 2 fractions together, I get 43 4/4, which is the same as 44 gallons. Now I need to go ahead and add 50 2/3 plus 8 3/8. And so 50 2/3, 50 2/3 plus 8 3/8. So I'm going to go ahead and change common denominator to 24 here. So I'm going to multiply the top and bottom by 8 for 2/3 to get 50 16 24ths plus 8 and 9 24ths. So I multiply the top and bottom by 3 for that one. And then I'm left with 58 and 25 24ths. And when I simplify that, I have 59 and 1/24. And so what I'm going to do is I'm going to take this number, 59 and 1/24. I'm going to add it to 44. And when I go ahead and do that, it comes out to 103 and 1/24 gallons after I add all the fractions. So the biggest thing is, don't worry about how big the whole number is. Focus on the fraction. Make common denominators and follow through with the steps on how to make equivalent fractions. So for question number 2, how much more water was used for laundry than cooking? And so here we have the laundry amount. So the laundry amount is 33 and 1/4. And we're going to subtract that from 10 and 3/4. Thankfully, this already has a common denominator of 4. But for this one, I need to borrow from the whole number here because you cannot subtract 1 minus 3. So when I go ahead and do this, 33, I'm going to borrow one whole to make it 32. So I'm going to have 32 and 5/4. All I did was I added 4 to 1 to give me 5. So I have 32 and 5/4 minus 10 and 3/4. When I subtract these, 32 minus 10 is 22. And then 5/4 minus 3/4 is 2/4. And when I simplify that, I can simplify that to 1/2. And so how much more water was used? I can say 22 and 1/2 gallons more water was used for laundry than cooking. So our friend Leo is designing a circular tabletop with a diameter of 10 feet. So before we even start these types of problems, write down on your paper the diameter is 10 feet, and then your radius is going to be half of the diameter. So the radius is 5 feet. So make sure you take your time and write that step first, because that's going to help you when you go ahead and use the circumference and the area equations. So our next step, number 1, which is the closest to the circumference of the tabletop? So for the circumference is pi times diameter. So I can say the circumference is equal to 3.14 times 10. So the circumference is going to be somewhere around 31.4 feet. So what I'm going to do is I'm going to go ahead and make sure that I double check and I circle the correct answer of 31.4 feet. So for question 2, which is the closest to the area of this tabletop? So the area is pi times radius squared. So remember, we're using radius for the area problem. So area is 3.14 times 5 squared. So 5 squared is 25 times 3.14 for the area. And when I do this, the area is going to be pretty close to 78.5 feet squared. And so what we're going to do is we're going to make sure that we circle, or you're going to use your pointer tool and click B for the correct answer there. So the biggest thing in solving these problems, figure out what your diameter and your radius are first. That's going to help you to figure out to use the equations properly. So here this triangle represents a section of a garden. The figure is not drawn to scale, which is kind of obvious because we're dealing with meters. And we know that little dotted line is nowhere close to 3 meters. It comes out to about a little over 9 or almost 10 feet. So obviously not drawn to scale. But anyway, so the question is, what are the area and perimeter of the garden? So the area of a triangle is equal to 1/2 the base times the height. So what we have to do is let's figure out what the base is. So the base is this whole entire line going across. And so we have two numbers. We have 4 and 13. What we can do for our base, let's go ahead and add those together to get a total for our base of 17 meters. So our base is 17 meters. And our height is 3 meters. So what we're going to do is we're going to go ahead and multiply 3 times 17. And then we're going to go ahead and, when it's all said and done, we're going to divide by 2. So what we can do is you can go ahead and use your calculator for this type of problem. 3 times 17 should give you 51. And then 51 divided by 2 will give you an area of 25.5 meters squared. So that's going to figure out your area. So the second question is, what's the perimeter? And so for the perimeter, we have to figure out what are all of the side lengths, and we're going to add those together, all the side lengths. And so we already know that our base is 17 meters, and then we have 13.3 meters and 5 meters are the 3 numbers we're going to focus on for our triangle, because the triangle has 3 sides. So let's go ahead and add all these together. So 17 plus 13.3 plus 5 gives you a perimeter being equal to 35.3 meters. And so the biggest thing is, on this type of problem, make sure that in figuring out this base all the way on the bottom, make sure you add those 2 numbers together to get the full base. So a car salesman sold 40 cars last month. The circle graph shows the results of the car by color. So we need to identify the car color that most likely represents exactly 10 cars. And so the way we can do this is, we know that this blue right here is half of 40. So what's half of 40 is going to give us, so blue is going to give you 20 cars. And then let's go and figure out our next biggest piece here. And so our next biggest piece is green. So green is 1/4 of 40. So when we go ahead and we multiply those 2 fractions together, or what you can do is do 40 divided by 4. So green will give you 10 cars sold. And so here you have 30 cars total that were sold. And then you have red and purple sections. So you can see for red and purple, both of those are equal to green. So both of those are going to be 5 cars apiece. So for question number 1, identify the car that represents 10, identify the color that represents 10 cars. So you can say that color is going to be green. And then we're going to identify 2 car colors that most likely represents a combined total of 25 cars. And so for this one, the first one's going to be blue, because blue is equal to 20. But you can use purple, has 5 cars, or you can use red. So if you put blue and purple, or you can also put blue and red, those are going to give you 25 cars. And so for this type of question, pay careful attention to the total number of cars, and then figure out your biggest piece is most likely going to be half or maybe a third, but most likely it's going to be half. And you're going to end up with whole numbers in each part, especially for cars, because you can't have half of a car. You're not selling half of a car to anybody. So most likely you're going to have whole numbers there. Figure out all the pieces and then go ahead and answer the question. So Bob asked a group of people to identify their favorite vegetable. The circle graph shows the results. Which graph on the next slide could represent the same data here? And so here you have beans wins out as their favorite vegetable. And then you have corn is second. So corn's the second biggest. So we got beans, corn, and then broccoli is third. Carrots is fourth. And our friend the asparagus is last. At least a couple people like asparagus. So in your circle graph, here you have to figure out which bar graph represents the same data here. And so you have 3 choices. The first step is that you have beans as the biggest piece. So beans should be the biggest bar. And so here you have the first graph has beans as the biggest. The second graph does not, so let's cross it out. And the third graph could also be an option. So now let's figure out what our smallest piece is. And so our smallest piece is asparagus. And so we can see that both of these have asparagus as the smallest piece. So here you have broccoli and you have carrots. And you see that broccoli is a little bigger than carrots. And so here when I look at this graph, for the first graph, carrots and broccoli are exactly the same size. So that means in this circle graph, carrots and broccoli should be exactly the same size, but they're not. So cross that out. So that leaves us with the third option to choose from. And so pay careful attention to each piece and make sure you compare all the pieces before clicking on an answer and moving forward. So Jill recorded the number of pull-ups each of the 10 students did on this line plot. What is the balance point for this data? And so here we already know that there should be 10 X's represented on the line plot. So let's go ahead and count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Nice. We have 10 X's that are represented because I just counted all the X's. Now we have to figure out the balance point. So we have to figure out what the mean is for the balance point. This is going to take a little bit of time, but I know you're going to be able to do this. And so each X represents the number in the category here. So what we're going to do is, great first step is to write out all the data. So we're going to write out 10 numbers. So we have 2 X's on number 1, which means that we're going to write the number 1 twice. So for number 2, I only have 1 X, so I should have 1, 2. For number 3, I have 2 X's, so I write 3 twice. 4, 5, 6, and 7 do not have any numbers. And 8 shows up 1, 2, 3, 4, 5 times. So I'm going to write 5 8s. 2, 3, 4, 5. So first step is get all of our data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you can get that step, the next step is to find the mean. You need to add. So step 1 is adding all the numbers together. So that's not a hashtag, that means numbers. Add all the numbers. So in your calculator, 1 plus 1 plus 2 plus 3 plus 3 plus 8 plus 8 plus 8 plus 8 plus 8 equals a grand total of 50. So when I added all of the X's together, so I added up all of the data, it equals 50. So then in my second step, what I have to do is I have to take 50 and divide it by the total number of students. And so the total number of students is 10 students. And when I go and divide 10 goes into 50 5 times evenly. So I can say that my balance point, or the mean, because we're figuring out the mean for this problem. Anytime you see balance point as mean, is going to give you 5. So our friend Andy surveyed his friends to determine the number of books each of them read in February. Here are the results of the survey. So each student represented here. So student 1 read 3 books, 2 books, 3 books, 19 books in February. That's a lot of books for February. 2 books, 1 book, 2, 2, 2, and 2. So first question says, what is the mean for this data set? So all we're doing is we're adding them together and dividing by the total number. So we're going to add them all together. Add them all together to find the mean. So 3 plus 2. So 3 plus 2 gives you 5. Plus 3 gives you 8. Plus 19 gives you 27. Plus 2 gives you 29. Plus 1 gives you 30. And then plus 2 gives you 32. Plus 2 gives you 34. Plus 2 gives you 36. Plus 2 gives you 38. So 38 is the total. And we're going to divide that by the number of X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we divide that by 10. The mean for this data set is 3.8 books. So that's an average for the number of books that were read for these students in February. So our second one is we need to find the median. So in finding the median, what we have to do is we have to line up these numbers from least to greatest first. So I have 1, and then I have 2 listed, 1, 2, 3, 4, 5, 6. So I have 2 listed 6 times. 1, 2, 3, 4, 5, 6. And then I have 3 listed twice, 3 and 3. And then I have 19. So in all, I should have 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then what I'm going to do to find the median is I'm going to cross out the smallest number and the biggest number. Smallest number and the biggest number. I'm going to keep doing that until I get to the middle. And I have 2 numbers left over. So all I do is I add these 2 together. So 2 plus 2 gives me 4. And I divide it by 2 to give me the median of our data set is 2 books. So the question for the third one is the mean or median a more appropriate measure of center to use for this data? And so you can see our data is really close together except for number 19. 19 is what we call, 19 is the outlier. So anytime there's an outlier, median is going to be the best choice. So students need practice identifying the common ratio and common difference. So those are the 2 keywords for sequences. So we have to identify what the common ratio is. So the common ratio, all that's telling you is what number am I going to multiply by to get to the next number. And so 5 times what gives you 25? I can say that the sequence, the common ratio of the sequence is I'm multiplying by positive 5. So there's the rule. The common ratio is 5. So what's the common ratio of this sequence? 3,125, 625, 125, 25, and 5. So the rule for this is you can write it 2 ways. You might see it either way. You can see it as n divided by 5, or you might also see it as n times 1/5. And so sometimes it's going to ask you for, it might say divide by 5. But if it asks you for a fraction, the fraction, when you multiply by a fifth, is the same as when you divide by the denominator, 5. And so I can say that the common ratio for question number 2 is 1/5. So what's the common difference of the sequence? So the common difference is when you either add or subtract. So if I go from 55 to 58, I'm adding 3. 58 to 61, I'm adding 3. So the rule is n plus 3. And the common difference is going to be 3 for this problem. And then what's the common difference of this sequence? So common difference is the thing I'm finding. To go from 67 to 64, I'm taking away 3. So the rule is going to be I'm taking away 3. Or it might ask you just for the number. In this case, you're going to add the negative sign in front of 3 because the numbers are going to get smaller for that one. So if you just put 3 as a common difference, 3 telling you that the numbers are getting bigger in the sequence, but by adding that negative sign, that's telling me that you're saying that this sequence, the numbers are getting smaller. So now let's go ahead and solve each equation here. And so what we need to do is we need to do something to undo the operation where the variable is located. And so for question number 1, you have 2x is equal to 4.8. In this case, to get x by itself, I'm going to go ahead and I recognize that 2x is multiplication. The opposite of multiplying is dividing by 2. So I can say that for this problem, x, because the 2 and the 2 cancel, is equal to 4.8 divided by 2 is going to give you 2.4. So for number 2, m divided by 2 gives us 4.8. And I'm recognizing that m divided by 4, that's division. So the operation that undoes division is multiplication. So I need to multiply both sides by 2. The 2's cancel, so I'm left with m being equal to 4.8 times 2 gives me 9.6. So now I have question number 3 here. So question number 3 is c divided by 6 gives me 0.6. I recognize that I have division here, so operation that undoes division is multiplication. So I'm going to multiply both sides by positive 6. So the 6's cancel, so I'm left with c is equal to 0.6 divided by 6 gives me 3.6. And then for number 4, the operation that undoes subtraction is addition. And so for this problem, I'm going to go ahead and add 6 to both sides. So I have c being equal to 6.6. So the biggest thing for these problems is to take your time, figure out what operation undoes where the variable, where that letter is, and then make sure you do that to both sides. Take your time and double check your work here.